what we're going to cover is one of those topics that's going to quietly change the way you see your own behavior for the rest of the week and possibly for the rest of your life, right? Today's episode is called Reverse Prompt Engineering, and the central idea is the most sophisticated attackers in the threat landscape right now are not breaking into systems. They are reverse engineering humans. They're using the same methodology that AI engineers use to figure out how to get a model to comply. Studying inputs, observing outputs, testing variations, and they're applying it to specific people. Your CFO, your procurement lead, your on-call engineer at 2 a.m. The human is the model, the attacker is the prompt engineer. And unlike every AI you've developed and deployed, the human has no system prompt, no red teaming report, it's zero awareness that that they're being prompted. So let's talk about it today. Picture an AI prompt engineer. They're working on a complex task, getting a large language model to reliably produce a specific type of output. They don't just write one prompt and call it done. They're writing 200 variations, testing different framings, adjusting the context window, and seeing what kind of information is present before the ask. They're modulating the temperature, studying the failure modes, and see what actually makes the model refuse information. What makes it hedge? What makes it fully comply without friction? What are those, pressure points that we can say? After 3 weeks of systematic testing, you find it. The exact phrasing, the exact context state, the exact framing that consistently produces the output that you need. They documented, they found the key to the model, right? Look at the same scene, but a different actor and a different target. A threat actor has passive access to a CFO's email system, but they're not reading the content. They're studying they're not studying headers. They're not looking at metadata. They're looking at what kind of behavior does this CFO do. They know the average email response latency is by the hour of the day. They know exactly which calendar blocks precedes fast inbox clearing behavior. They know that on Thursdays between 4:30 and 5 p.m. after the 3 p.m. all hands wraps up late, they process outstanding approvals at a pace that's 40% faster than the usual Tuesday morning baseline. They know that wire transfer requests arriving in that window from email addresses that pattern match to the specific controller's domain, they get approved at nearly twice the rate of identical requests sent at other times. You don't need to craft the world's best convincing phishing email anymore. We've got phishing tests for all of that. You just need to send a competent one at 4:47 p.m. on a Thursday, 2 minutes after the last calendar block ends, with a subject line that looks like it belongs in the higher approval queue. And with that, the wire transfer goes through. The prompt engineer and the attacker used identical methodologies, but only one of them had ethics. That's the frame for today. Let's unpack it with our 3 lenses. Let's start with the threat landscape, because I want to ground this in what's actually documented before we get into mechanisms. So business email compromise, also called as BEC, is now a multi-billion-dollar category. The FBI's IC3 puts losses in the range of $3 billion annually in the US alone. And that's almost certainly an undercount because most corporate BEC losses don't get reported publicly. But here's what's shifted in the last 3 to 4 years that doesn't get enough attention. The sophistication is no longer the primary artifact. It's in the timing. Early BEC was content focused. Make the email look like it's from a CEO, get the domain right, no spelling mistakes, match the signature, spoof the display name. That's still a baseline requirement, but it's table stakes now. The real differentiation among sophisticated threat actors is behavioral intelligence, not making the email look right, but making it arrive at the right moment. There's documented evidence across incident response reports from Mandiant, SecureWorks, and several published threat intelligence briefs of threat actors who, after gaining initial access to an email environment, they spend 3 to 6 weeks in passive observation before triggering any action. They're not exfiltrating data immediately because they are so sure that they've already, made it. They don't move laterally. They're just watching. They're building a behavioral model. They're learning the approval patterns, the decision rhythms, the cognitive geography of specific individuals. And what they're looking for is what I'd call the compliance window, the period of time when a specific target is most likely to approve a request without the friction they'd apply at other times. The business windows, they're real. They're predictable from behavioral data. And they're surprisingly narrow. We are talking sometimes 15 to 20 minute windows that recur on weekly or even daily cycles. The timing dimension of BEC gets almost no attention in most threat intelligence reporting, which focuses on indicators of compromise, malicious links, spoof domains, payload characteristics. The timing is invisible to most detection systems because it is not an anomaly in the message. It is an anomaly in the attacker's behavior that happened weeks before the malicious message was ever sent. Now layer in what's happening in the data broker ecosystem, because this is the supply chain story that most people in security aren't tracking close enough. The behavioral data exhaust that modern organizations generate is enormous. Emails, metadata, calendar data, Slack activity, access log patterns, meeting attendance. A lot of this data, particularly around individual behavioral patterns, finds its way through SaaS vendor agreements, through HR analytics platforms, through productivity monitoring tools, into data broker pipelines. And the data brokers are no longer just selling demographics, they are selling behavioral prediction scores. Likelihood to click on an unsolicited link, likelihood to approve a financial request under time pressure, likelihood to comply when an authority figure is invoked. The scores are used legitimately by marketers to rank and sequence outreach campaigns. The same scores derived from the same data can be used to rank and sequence attack targets. You don't attack the hardest target in the organization first, right? You attack the highest scoring complier in the approval chain. This is not speculative. The data broker industry sells behavioral prediction products to enterprise marketing and sales teams as standard practice. The threat intelligence implication is that an attacker with a budget, and sophisticated BEC groups absolutely have budgets, they can purchase a behavioral profile on a target before they even touch the target systems. But what does this mean for defenders? It means the attack surface is not just your perimeter, your endpoints, your cloud tenants. It's the behavioral data exhaust of your people. And almost no organization is treating this as sensitive infrastructure. Alright, let's move to the AI layer, because this is where the threat scales in ways that are genuinely new. The mechanism I just described, an attacker spending weeks manually studying a single target's behavior patterns, is extremely labor intensive. It requires skills, patience, and time. It's feasible for high value targets, CFOs, procurement leads, senior engineers with privileged access, but it doesn't scale. You can't manually reverse engineer the compliance profile of every employee at a mid-sized enterprise. Could you? Because AI changes that calculus completely. Here's why. The behavioral data I described, email response latencies, calendar patterns, Slack activity, Windows, access logs, it's structured, time-stamped, and highly amenable to machine learning. You don't need novel AI to build predictive compliance models from this data. That's what enterprise UX analytics tools and marketing AI systems have already been doing routinely. They identify patterns in behavioral sequences that predict decision outcomes. They find the variables that, when combined, most reliably predict a specific behavioral output. Legitimate companies use this to optimize when to send marketing emails, to determine which UX flows will give the highest conversion rate, to figure out when to trigger a nudge in a productivity application. The same capability, and in many cases the same tooling, can be directed at building compliance profiles for attack targeting. What does an AI-generated compliance model for a specific individual look like in practice? It's a predictive function that takes as input the time of the day, the days of the week, preceding calendar activity, email volume in the prior 2 hours, recent approval history, and current active context, and then outputs a probability score for compliance with a specific type of request. Specific request. Build that model for enough individuals and you can rank an entire target list by current compliance probability in real time. The personalization layer is equally important. We talk a lot about AI-generated phishing as content problem, right? AI can write more convincing emails, more plausible pretext, better grammar. That's real. Not denying that. But it's not the deepest issue. The deepest issue is that AI can now generate personalized attack messages that are optimized not just for generic plausibility, but for that specific individual's compliance profile. Think about that. What framing does this person respond to? What authority signals have produced compliance in the past? What level of urgency is effective without triggering skepticism for this specific target? An attacker with a behavioral dataset and an AI that can process it isn't running one attack message at scale. They are running personalized prompt engineering at scale. One message from each target, each message optimized for that target's specific compliance profile is more than enough now. This is the reverse prompt engineering that I'm talking about. You can even call it human engineering. Now here's the defender blind spot, and I want to be precise about this because it matters for how we think about detection. Most security tooling is looking for content anomalies, malicious links, right? We've already talked about this, spoof domains, payload signatures. We're looking for sender anomalies, first time senders, unusual communication patterns for a known contact, geolocation mismatches, DNS mismatches. These are all valuable and necessary signals, but they're all looking at the attack artifact. None of them are looking at the timing and the framing patterns that indicates a human is being prompted. The signal that something anomalous is happening is in the attacker's behavior, the observation period, the timing correlation between message delivery and behavior compliance windows, not in the message content. Building detection around behavioral timing patterns is technically feasible. If you're logging email metadata with timestamps, calendar data, and approval events, you can build anomaly detection around the correlation between message timing and approval outcomes. If a wire transfer request arrives within a 15-minute window that consistently follows a specific calendar pattern for a specific approver, that's a signal worth flagging. Not because the content is suspicious, but because the timing fit is suspiciously good. Almost no organizations are doing this. The data exists, the tool to process it exists. The conceptual frame, treating timing correlation as a detection signal, that's the gap. Now let's dive into the psychology layer, because this is where the mechanism actually lives, and I think is the most underappreciated dimension of the threat. Robert Cialdini's 6 principles of influence, which is reciprocity, commitment, consistency, social proof, authority, liking, and scarcity. These have been part of security awareness education for years. We teach people that attackers use urgency and authority to bypass critical thinking. That's accurate, but it's incomplete in a way that matters. Because the old model is, here are the levers that influence humans, attackers use the levers. Learn to recognize them. The new model is, knowing which lever to use is not the hard part. Knowing when that lever may be maximally effective for a specific individual, that's the capability that's changed. Research in decision science and behavioral economics is quite clear on this. Human compliance rates are not stable. They vary significantly, by up to 40% in some control studies, based on time of day, cognitive load, recent decision history, and current emotional state. A person who's generally skeptical and thoughtful can become a fast approver when they are context switching between tasks, running low on decision bandwidth, or operating in the time frame where the mental model is clear the queue, not evaluate the queue. Fatigue doesn't just make you tired. It changes the computational model you're running. Under high cognitive load, the brain defaults to heuristic processing, pattern matching, authority deference, urgency compliance, rather than analytic evolution. An attacker who can predict when a target will be in that state is not attacking the person at their baseline. They are attacking the person at their worst moment, with a request calibrated to that moment. And here's the framing I find most useful. The idea of the human system prompt. In large language models, the system prompt is the persistent instruction that shapes how the model responds to subsequent inputs. It sets the context, the role, the constraints, the disposition. A model's responses looks very different depending on what is in its system prompt. Humans have that equivalent, not a technical artifact, but a persistent psychological state that shapes how we process incoming requests. And this is the fun part. Our current stress level, our active identity context, are we in approver mode or evaluator mode right now? Our trust calibration in the environment. Do we feel like we are safe in a familiar context or unfamiliar? Our recent experience of authority. Have we been deferring to others all morning, which makes one more deferral feel natural? Sophisticated attackers are learning to set this state before the ask. A series of low stakes rapport building interactions before a high stakes request. A communication that references a trusted recent event to establish contextual familiarity. An initial contact that invokes authority in a low friction way so that by the time the actual request arrives, authority deference has already been primed. This is not hypothetical. It's documented in social engineering case studies, in red teaming reports, and in the academic literature on influence and compliance. What's new here is that the data infrastructure now exists to do this at individual level, and with AI, it's at precision and scale. Now I want to address the meta level because it's the most psychologically interesting part. Once you understand this framing, right, that you can be reverse prompted, that your behavioral data exhaust is being used to build a compliance model, that the timing of a request is not incidental but maybe precisely calculated, what's your natural response? It's hypervigilance. You start second guessing everything. You start adding friction to every decision. You treat urgency as a red flag rather than useful information. You look for like the angle in every communication. But here's the problem. Hypervigilance is itself significant cognitive load, and sustained cognitive load degrades decision quality. If the awareness of the attack is causing you to run an exhaustive mental security scan on every incoming communication, you are burning that decision bandwidth that you need for the actual work. And when you hit decision fatigue, which you will for sure, because hypervigilance is not like a sustainable state, you may be more vulnerable than you were before you understood the threat. And this is not an argument for ignorance, right? It's an argument for structural solutions rather than individual vigilance. I'll come back to this in the takeaways, but the psychological point here is awareness of the threat changes your threat surface. The attacker who understands that you are now hypervigilant can model that too. Your predictable responses to awareness is also data. So let's pull these three threads together, because this is where things get genuinely new. We have a cybersecurity threat, which is BEC and social engineering, that has evolved from content quality to timing precision. The attack capability is no longer primarily about making artifacts convincing, it's about delivering the right artifact to the right person at the right moment. Then we have the AI capability, behavioral data processing and predictive modeling, that can automate the identification of these moments at scale and can generate personalized attack communications optimized for each individual's compliance profile. And we have a psychological reality that human compliance is not stable, that it varies with cognitive state, that the brain can be primed and the compliance window can be predicted. That gives the above two elements their attack surface. What makes this a genuine inflection point rather than just an incremental threat evolution is the combination of scale and precision. High precision social engineering has always existed. Master manipulators and skilled con artists have always been able to read people and find the moment. What's new is that the AI can industrialize that capability. The reading doesn't have to happen in person over time through social interaction. It can happen computationally from structured data across thousands of targets simultaneously. The organizations most at risk are not necessarily the least security mature. Think about that. They're the ones with the most behavioral data exhaust, large workforces, highly instrumented SaaS environments, lots of approval workflows, rich calendar and communication metadata, combined with approval processes that concentrate decision authority in a small number of individuals. That's a lot of large security conscious enterprises, if you think about it. The defender posture is that this requires is different from the posture we've built. We build defenses around artifact detection and access control. What this threat requires is behavioral pattern monitoring, approval workflow friction that's independent of individual decision state, and a much more serious treatment of behavioral data exhaust as sensitive infrastructure. Let me work through the three levels of implications: individual, organizational, and societal. At the individual level, the most important shift is recognizing that your behavioral patterns are a security surface, not just your passwords, not just your access credentials. The rhythms of how you work, when you decide, how you respond to authority signals. These patterns are observable, collectible, and predictable. This doesn't mean you need to become some paranoid schizophrenic about every Slack message you get or send. It means that certain behaviors, particularly high-stake approvals, deserve structural protection that doesn't depend on your individual vigilance at the moment of request. At the organizational level, the threat I've described demands a re-examination of how approval workflows are designed. A wire transfer that can be approved by a single individual in a single email interaction with no secondary confirmation, that's temporarily separated from the request, that's a workflow designed for speed, not security. The insight from behavioral compliance research is that time separation is a significant protection. An attacker who can find a compliance window can exploit a same session approval. They cannot exploit a workflow that requires a second confirmation 24 hours later because they cannot guarantee that target's compliance window will be open again on demand. Organizations also need to think about behavioral data exhaust as infrastructure. The metadata your email system generates, the pattern your calendar and communication tools expose, this data has security implications that are not currently reflected in most data governance frameworks. Who has access to this data? Which vendors are processing it? What are the downstream data sharing practices? These are questions that belong in your data risk assessment, not just your marketing analytics review. At a societal level, the implications are harder and long range. We are building an information environment where behavioral prediction is the underlying commodity. The same data and modeling infrastructure that enables predictive compliance attacks is what powers recommendation algorithms, personalized advertisements, credit scoring, and insurance pricing. The capabilities are not separable. You cannot selectively disable behavioral prediction for malicious actors while enabling it for legitimate commercial use, because the data flows in the same broker pipelines and the same modeling frameworks. The policy question that raises, and I'll leave it as a question because I don't want there to be like clean answers. What is the level of behavioral predictivity that we are comfortable having as a social baseline? At some point, if your compliance profile is accurate enough and widely enough distributed, the distinction between manipulation and communication starts to break down. Every message you receive is potentially a message calibrated for you. And we are seeing this already. That's a fundamentally different epistemic environment than the one we designed our institutions, our laws, and our social norms around. And we're seeing this in a lot of enterprises where you're processing a lot of data to start putting hyper-personalized advertisements. Okay, let's make this actionable. I said at the top that this isn't fear-mongering. It's a practitioner's conversation. So here are 4 specific things that you can actually do. 1. Vary your patterns deliberately. If your behavioral patterns are predictable, they are exploitable. This doesn't mean you should introduce chaos into your work life. It means that for high-stake behavior, particularly approval workflows, you should consciously introduce variability. Process wire transfer requests at different times. Review financial approvals from different devices and locations when possible. Don't let your high-stakes decision cluster into predictable windows. An attacker who can predict when you will be in a compliance window can reliably time the attack. Behavioral unpredictability, specifically around high-stakes decisions, is a genuine security control. Second, treat your behavioral data exhaust as sensitive infrastructure. Audit which tools have access to your communication metadata, calendar data, email response patterns, Slack activity logs. All of this behavioral data that can be used to build a compliance model, monitor it. Ask your SaaS vendors what data they collect, how do they process it, and what's their downstream data sharing practices. Include behavioral metadata into your data classification framework. If you classify the content of a CFO's email as sensitive, you should also classify the metadata of those emails, response times, volume patterns, approval history as sensitive as well. Most organizations don't. Fix that. 3. Build structural friction into high-stakes approval workflows. Don't rely on individual vigilance at the moment of your request. Design your approval processes so that the friction is built into the workflow, not into the individual's decision state. Specific mechanisms, for example, will require a temporal gap between the request receipt and the approval action. Even a 2-hour cooling off period changes the attack calculus significantly. Require out-of-band confirmation for high-value transactions, a phone call to a known number, a secondary authentication that's not in the same email thread. Require dual authorization that involves 2 people who are unlikely to be in a compliance window simultaneously. None of these are novel ideas. What's new is the behavioral intelligence argument for why they matter. Not just because humans make mistakes, but because a sophisticated actor can predict and exploit a single individual's compliance window. 4. Build detection around timing correlation, not just content anomalies. For security teams, start logging the correlation between message timing and approval outcomes. If your financial approval workflows generate structured data, request received, approval granted, time delta, you can look for these patterns where the timing of high-risk approvals correlates suspiciously well with known behavioral patterns of the approver. You're not looking for a malicious link, you're looking at when that request came in. This requires integrating email metadata, calendar data, approval workflow data into a single analytic view, which most organizations today don't have. It's worth building. That's the data here. We started today with 2 people using the same methodology, a prompt engineer finding the key to a model, an attacker finding the key to a CFO. The same systematic process of observation, variation testing, and behavioral pattern analysis. One of them had ethics, the other did not. The point isn't that humans are machines. The point is that our behavior is patterned entirely. Our patterns are observable entirely. Our observations are now processable at scale. And the compliance outputs are predictable within limits that are narrow enough to be operationally useful to an attacker. Understanding that you can be reverse prompted doesn't make you immune to it, but it does change the kind of defenses that make sense to build. Individual vigilance operating at the moment of a request is the weakest form of defense, and as we discussed, the most exhausting. Structural controls, workflow design, data governance, and anomaly detection built around timing and correlation. Those are the defenses that don't depend on you catching it at the moment. And that's what productive paranoia looks like. Not scanning every email for red flags, designing systems where a missed red flag doesn't result in a wire transfer. If you found this useful, and I hope you did, please subscribe to the Intersection Talks and find us at Substack on synthesection.substack.com, where we go deeper into topics we cover here with written analysis, case studies, and the occasional model or framework that you can actually use. Thank you for listening to the Intersection Talks. You could have been anywhere in this world listening to any video, but you listened to this entirely. Thank you. Please put in your comments down below. See you at the next video in the Intersection Talks.